So hi everyone, today we'll see thread lifecycle and we'll do its implementation also. Okay, so first we'll go through this diagram and understand the thread lifecycle and its methods. Then we'll implement it in the editor. Okay, so first when a thread is created, it will be in a new state. Okay, and new state means when it will call the start method, then it will go to runnable state. Okay, runnable state means my thread is active, but it is yet to pick up by the thread scheduler to make it run. Okay, so when the thread scheduler pick up my thread, it will call the run method, and my thread will be currently in running state. Okay, now after this run method is complete, then my thread will be directly going to the terminate state. Okay, there can be another way that my thread will go to terminate state. Suppose if there an exception occurs inside my run method, whatever logic I have written, if there any exception, at that time also my thread will be go to the terminate state. Okay. Next there is another two key stages of this thread life cycle. One is blocked state, another is waiting state. Okay. Blocked state means if my thread is acquiring any lock or if my thread is if we call the thread.sleep method at that time my thread will be go to blocked state. Okay, and waiting state means suppose if my current thread is waiting for another thread to complete its operation, at that time it will go into the waiting state. Okay, when my current thread going to the waiting state, at that time it will call the wait method, and to reactivate the current thread it will call the notify method. Okay, so this is all about the thread lifecycle. Okay, and now how we'll create thread in Java. Okay, there are two ways to create thread. First one is by extending the thread class, and second one is by implementing the runnable interface. Okay, so let's go to the editor and we will implement it, and let's see. So currently I am in my IntelliJ IDE, and let's implement the faster tool, that is create the thread by using extending the thread class. Okay, so here I have created a thread package, and here I will create a new class named as I'll give this name as my thread, and here what I will do, I will extend my third class to it. Okay, and after then I will override the run method, and this thing is not required. I commented this thing, and after then I will the system out println, and I am giving my uh, thread is running. Okay, now to run this class I will create a main class. Uh, so I'll give this name as my class. Just put the naming convention correctly. Okay, now what I'll do here, I will create my main method here, and inside my main method what I'll do, I'll create object of my third class equal to new my thread, and I'll call my run method again. Okay. So now what it will do, what I have did so far. Okay, I have created a my third class, and to this my third class I have extended my uh, third class to it, and then I override the run method of third class, and inside the run method I have added one println statement. Okay, and then to call this run method I have created a main class. Inside this main class I create the object of my thread, and I have called this thread one dot start. Okay, so as I said in thread lifecycle that when I call the thread one dot start, it will wait for the scheduler to pick up my thread, and when it is the scheduler picks up my thread, it will call the run method automatically. Okay, now let's see what is happening. Okay, now if I run this, see, it is showing my thread is running. Okay, now so I have created, I overridden my run method. Okay, now what will happen if I directly call my run method? Okay, so any guess what will happen? So let's implement. Okay, so if I directly call my run method, let's see what is happening. It is calling the same println statement, okay, every time. But here is a catch, okay. Let me show you one thing. So inside my thread, I am creating, I'm adding one method, okay, to get the name of the thread. So what I'll do, I'll create thread dot my current thread, sorry, thread dot current thread dot get name, okay. It will give my name of the thread what it will be executed, okay. And if I save this, I'll run, but it will show in the output. It is showing that there is a thread 0 and there is a main, okay. Why it is printing so? Because my thread 1 dot start, it will create a thread object for me, okay, new thread object for me. For the thread 1 dot run, when I call directly to the run method, it will pick up the my current threads name, okay. My current thread will be always that is void main. So this is inside my main method only it is done. That's why it is showing me my main thread, okay. For thread 1 dot start, it is creating a new thread for me, okay. That's it is saying thread 1 dot thread 0, okay. Okay, let's implement the second approach, that is by implementing the runnable interface, okay. For that I'm creating a new class and I'm giving the name as my runnable, and here what I'll do, I will implement my runnable interface, implements runnable. Here I also override the run method, okay. And here I also add a print statement, that is my thread inside runnable interface, okay. Okay, I save this. And to call this my runnable class, what I'll do, I'll create object of my runnable equal to new my runnable, okay. Now if I create an object of runnable, I can't directly do runnable dot start, okay. So to call the threads run method, I have to create a thread, and I'll create this will be my thread test, and this will be my new thread, and I will pass this runnable subject to my thread object, okay. I'll pass this runnable and I will do directly thread test dot run, okay. Now it will run, okay. Let's see it is running or not. If you see, this is run, the thread is inside runnable interface, okay. Now why it is so? Suppose I can easily do it using extending the thread class, right? Why I will go for this complexity? I will create my runnable class, I will implement the runnable interface, then I create object of runnable, I'll pass this object to thread object, then I will call the run method, okay. So now if, if you are working on some big project, at that time there is sometime happen that your class might be extending some another class, okay. And since Java is not supporting multiple inheritance, it cannot extending more than two class, okay. So at that time your implements enable will be helpful, okay. So let's say here I have a class A, and for this I have added one method called test, and here I have also system of println, that is this is test class, okay. Now inside this syntax I need to extend this class here, right, to use this functionality. This is extended, okay. Now to call this test method, what I'll do, I'll go to my class, and here what I'll do, using this runnable subject, I can call the test method, okay. Now if I save this and if I run, what it will do, see, this is test class is printing, okay. So when your um, So when there is a situation like you have already one class that is extending another class and you want to add the threads functionality, at that time we will go with runnable interface. Okay. So runnable interface also provides another functionality, that is reusability of the current thread object. Okay. How it will do so? So for this, what I'll do, I'll create another two object of my thread class. I just copy paste the same thing and I will change the name. I'll change it to 1, 2 and 3. Okay. Now with this runnable interface, I'm also passing another parameter, that is my this will be my part thread. This is basically the name of the thread. You can pass just like this also if you want to customize your thread name. Second thread, and this will be my third thread. Okay. Now to show this functionality that my thread class providing reusability, what I'll do, I'll add a counter variable here and initialize it with 0. Okay. Now what I'll do, I will use the same method to get the name of my current thread that is executing. With this, I am adding the uh, counter value. Okay. It will show me what is the current counter value. I am incrementing the counter value also by +1. I have added +1. Okay. So it will increment the counter +1 every time. Okay. Now I will go to my class. What I will do, I will call the start method of the thread. The test1.start. Remember, do not call the run method directly. Okay. You should go by step. First call the start method, then my scheduler will pick up, and then it will call the run method. Okay. You no need to call directly the run method. Okay. Now if I run this, so what you will see, so this is my current thread. First thread will be 1, second thread will be 2, my third thread value will be 3. Okay. Now this is my my runnable class. I have initialized the counter with 0 value, right? So what it will say, I have created 3 objects of the thread. Okay. But each time when each object is called the run method, it will increment the counter value from which my previous thread object's counter value lives. Okay. First count first thread object increment my counter value to 1. Second thread object increment my counter from 1 to 2, and third thread object increment by from 2 to 3. Okay. This shows that my runnable interface is providing reusability of the same functionality of what I have implemented inside my runnable interface. Okay, so that's it. Thank you. Bye bye.